About 20 years ago, they came up with this idea of education called STEM, S-T-E-M, science, technology, engineering, and math. And it was at that time, the National Science Foundation came up with this in order to try to get more people to come into those fields, so that the education started at a much younger age. And now you even hear and you see these things start to appear at elementary school level. About 5 years ago, they started to add this letter A in STEM, and now they call it STEAM. And A is supposed to stand for art. And so when I went to National Academy of Engineering conference, I asked them at that time, why add the A? And the first person answered, well, obviously it's to get more women in the field. And I looked at her thinking, wow, I don't know if that's correct. And it was really interesting because it was a woman who was a dean of an engineering school. And I thought, wow, I hope that's not the answer. I hope you're joking. Then I asked someone else because I wasn't really satisfied with that answer. And basically, they're trying to say that the National Science Foundation, the Department of Energy, the Department of Defense, all these organizations are getting very concerned because even though a lot of innovation is happening in the United States, it is not getting to market. Somewhere there's a big gap that it gets to market in Europe or abroad a lot faster. And so they're concerned about that. They want to know why that's happening. And given technologies like the iPhone, like Tesla's, like all these different things, they're starting to realize the integration of the arts into this technology was very, very important. Since then, I have to say, even myself, I've been invited to speak at engineering conferences, at summits, and even at faculty retreats. And it's curious to me because I'm not an engineer. I don't have a PhD. I don't have a background in engineering, but I still get invited. So I asked them too. It's like, well, why me? Like, why are you inviting me to come to this type of thing and talk to engineers about design? And they said that's exactly it. It's the design process that they are, in some ways, coveting and seeking in their process. They're trying to figure out how to educate and improve the research in their departments, in engineering and in education. And the thing that I thought was really funny, because even in the work that I do, and I'm sure the panelists will talk about this too, I actually start to move in the other direction, and I start to incorporate the scientific process in my work, and how the scientific process is so critical because we actually have to build it and we actually have to make it work, which is a very big part of making. So it's in this area of design process, scientific method, that these two things start to come together. And as architects, we start to move in that direction. As engineers, they start to move in our direction. And where does it all meet? And that's, I think, one of the topics of what we're here today, and trying to learn what that can be done towards education and how it affects us all. So on that note, I'm going to ask again Junho to introduce the panelists. After that, they will each do a short presentation of their work, and we ask them also to speak about what they think about education and how it is education in architecture schools. And then afterward, we'll have a discussion, conversation to see what we can actually glean out of this as a group. So, Junho.
Thank you. I'd like to use this moment actually for kind of some advertisement. So before I introduce the great scholars that we invited. So yeah, School of Architecture at USC, we are doing a lot of effort to make a change in terms of some scholarly activity and research activity. So as you know, as announced last week, so we have some internal research grant program. So with the significant support of our current dean. So the deadline is March 6th, so all the faculty and all the students can apply for any specific program. So we have 4 programs, 2 programs for faculty for kind of travel fund support and the research fund, and then students also have a same format. And so if you're interested, please check the email that they sent last week, and then please apply. I hope to get many applications from you guys. Okay, great. So it is a great honor for me to have to introduce the 3 the presenters. So the first one is Dr. Davis. So Dr. Davis, she completed her PhD in MIT Design and Computations, and since then she worked as assistant professor at the Stockman Center for Design Computing in the School of Architecture and the Landscape Architecture at Pennsylvania State University. So her work is quite interdisciplinary. So her work is focusing on architecture and textile connect art, and science, engineering, and design. So she is currently the director of the soft lab at the PSU. Okay. Yeah, please welcome. Please join me to welcome. Okay. Is it?
Sorry, it's wrong. We could change it.
Oh.
We did Ron first.
Oh, okay. Sorry. Okay.
Mr. Ron, and just introduce them all right now.
Okay, sure. Okay. So, and we also have today the Professor Ronald Ryle. So, he is a professor of architecture at the UC Berkeley, and he's a founding partner of Oakland-based Make Tank Emerging Object. So he's working on the implication of border wall building with the mud and using 3D printers to create buildings. Okay? And we have the last but not least, so we have some Professor Jenny Sabin. So she is the professor of in architecture and associate dean for design at Cornell College of Architecture, Art and Planning. And she is currently the principal of Jenny Sabin Studio and experimental architectural design studio based in Ithaca, and the director of the Sabin Lab at Cornell AAP. So we will have some all the presenters. We will have three presentations in a row, and then after that we will have some Q&A session. So actually, I'd like to recommend you to check out this website so you can take a photo. So if you have any question, even during or after the presentation, please post your presentation. So after all three presentations, we will share your question so that we can do some discussion.
So we're going to start with Ronald Ryle. I'm going to put the. Yeah. And here, this is your.
Okay, thank you everyone for coming tonight. Let me figure out how to work this. That's me. And probably everything I think about in terms of technology is encapsulated in this image, in this particular building. For me, material doesn't exist without technology. You can't have a material unless you have a technology to manipulate or do something with it, and technology doesn't exist without culture. And also, that I don't see advanced technologies as being the newest. I think advanced technologies are those that we have been developing for the longest amount of time, and maybe some innovative technologies could be seen as the newest. But this building, called Casa Grande, was built in the 1400s. And out of the mud from the landscape. So there is not only a culture that's associated with the material, but there's also a landscape that's associated with the material. So these four things go hand in hand: landscape, culture, technology, and material. The materials that are used for the roof structure were placed there to protect this building in 1928. The designer of this won an international competition. His name was Frederick Law Olmsted Jr. He was the son of Frederick Law Olmsted. And he won this competition to build this canopy. And he believed that not only the materials being so radically different, but the distance of this roof away from this structure was what would give the earthen building below, built by the Hohokam, its prominence in terms of protecting it. However, what I think about this is that this is the birth of an entirely new way of thinking about architecture. It's the convergence of very old technologies and very new technologies, new materials and old materials, new ways of thinking about it, new landscapes. And so I'm interested in this because I come from indigenous building traditions and food traditions. In my own house in Colorado, I teach students how to continue these traditions of working with mud to make buildings. And I also teach students in the summer about indigenous traditional foodways, which is very different from the work I do at the university, but also not really, because I'm interested in how these kinds of materials and these kinds of technologies can be integrated into innovative technologies and new technologies. For example, this particular passive cooling system, which is like an old-fashioned swamp cooler where a ceramic vessel is placed in a window and filled with water, and the porosity allows the air, the warm, dry air, to be humidified and lower the temperature inside the room, is something that might be encapsulated in a very simple 3D printed brick with its porosity that can soak up water like a sponge and the porosity that allows air to pass through it. And so it's these ideas of thinking, looking back and looking forward at the same time that I try to impart to my students, and thinking about technology and material and culture. This is a project where the students were working on developing a kind of code that created a lattice work so we could take this structure and then hand plaster it with clay. So we built this we printed this in Berkeley. It was all shipped to France, and then we used the local clay in France to plaster it with clay, not unlike their building traditions of wattle and daub, where they take branches of sticks and they cover it with mud to build their houses there. So again, it's looking at how you create innovation by looking backwards in order to move forwards. It's not only clay that we're interested in, but many different kinds of materials and the landscape of those materials. If you've ever flown into the Bay Area, you see these beautiful multicolored ponds. These are salt crystallization ponds, so they fill these ponds up with water once a year, and over the course of the year they dry and they leave tons of salt crystallize in their wake. These are microorganisms that create this color while in the saline material. And we've thought, well, what does it mean to make a building out of that same landscape in the same way you would do out of mud, an adobe house? So this is a salty glue, and it's made out of salt and glue. We look at other materials like newspaper. Can you take newspaper and turn it into a powder and make it into a 3D print? For us, everything about this process, going from something that is a product, a material product, to something that is a material product, is something that we can trace its provenance. We can think about the history of the newspaper, the printing press, the 3D printer, the materials that are used to grind it, ultimately arriving at something that can be useful, something that allowed us to think about how we can 3D print sawdust, for example. And if we can 3D print sawdust, how do we begin to entice a way of thinking about turning what is a subtractive industry, starting with forests, to trees, to lumber, to sawdust, and turning it into an additive process that goes back into making buildings? And so many of the tiles that clad this building, which is a small cabin in Oakland, is made out of recycled sawdust, recycled Chardonnay grape skins from wine country, local clays and ceramics that are harvested locally, hanging on a 3D printed armature. But in order to do all this, we have to think about the culture, the landscape, the material, and we also have to think about the technologies and the technologies that are part of this, which are the software that allow robots to wiggle around and shake clay like this, but also the hardware, and we've begun to develop hardware to make structures like this faster and at larger scales. So a lot of, I think, what Doris was talking about in terms of science and art, like these two categories, in a way we don't think of them as different. We think of pure science, which is, it just only has to be interesting. It doesn't necessarily have to be useful. I think pure art, in a way, should be interesting as well. It doesn't necessarily have to be useful. So when we were first making these wiggly clay structures a long time ago, we were just interested in what that did. And later we realized that not only could we make a beautiful skin on a cabin, but we could make coral reef habitat. And we've 3D printed over 4,000 of these that are being tested all over the world now in Baja California and Australia and Guam. For coral larvae to attach to. And so these are through ceramic materials that were developed and through robotic practices that were created. And so alongside thinking about the development of technologies and development of materials, we're also thinking about how these go to market, or how they how the innovations we create in architecture don't simply sit on a hard drive or go in the trash, but they can be patented, and they can go out in the world. So I've been working with a student from Sudan who has this very famous stove called the Sudan stove, and millions of people use this stove in their homes. The problem with this stove is it produces a large amount of pollution from smoke, and people die from the smoke ultimately. So what we did, which was really interesting, is we made a smokeless version of this stove. Oops, can I play that video? And it works in this amazing way. So we took clay, harvested right from the site, we 3D printed that, we dug a hole in the ground, we fired the clay stove, and now, because of the particular design that recombusts the smoke right before it leaves the chamber, there's very little pollution relative to other stoves. So now we're thinking about writing grants to USAID and see if we can print 100,000 of these in the next 10 years and distribute them in sub-Saharan Africa. The last thing that I've been working on is thinking about, with students, how to teach them not the design of objects, but the design of movements, almost like dance, how to choreograph robots to make the things that they need to make. In this case, spaces for gathering, stairs, spaces for cooking, places to put food on, all made out of clay in this case. And so there's a lot of things happening here. Again, thinking about the process that I just outlined, where I'm thinking about materials and food and culture and technology, we've moved full circle, where now we've developed a large-scale robot where we can take mud and go out into the field and put it in the robot and 3D print a mud oven or a mud structure or a mud dome or a mud vault. Again, synthesizing these ideas that we don't think about technology first or material first or hardware or software first or culture first. We think about them, pushing them all together at the same time. Thanks.
Okay. That'd be great. Great. Thank you. It's a pleasure to be here this evening. Thanks for the kind invitation, Milton, Doris, and Junhoo. So I'm not going to spend too much time talking about my work, but I'm going to talk about how I work and how I teach, how I conduct research, how I collaborate. For me, technology is fundamentally human, and it's inextricably linked with material and making and the ways that we grapple with emerging technologies. I like to think of software as a new type of material. And I've been very careful over the years to not label myself a technologist. I'm an architectural designer who collaborates across disciplinary boundaries, where technology, such as visualization and simulation, making sense of big data, serves as a bridge for communication and understanding and ultimately the production of new knowledge. I started collaborating with a cell biologist in 2005, so 15 years ago, when I also started teaching. At that time, it was at the University of Pennsylvania, the Graduate School of Design. And there were many naysayers early on, people who wondered why the heck we were going to work together. Why would I work with a biologist? And I think, for me, over the years, the research and the applied projects in my practice keep me going and they keep me excited. But my biggest impact is through teaching and getting students to think a bit differently. And ultimately, the production of a hybrid model, a new model for pedagogy and collaborative research. And that means I don't sleep very much. I engage in core research in my lab at Cornell and applied projects in my practice. And in all of those entities, students are involved.
as interns, as research associates, learning how to write technical papers, and so on. We also contribute to fundamental research in science. Early on, my sort of longtime collaborator, Dr. Peter Lloyd-Jones, who's a cell and molecular biologist, we engaged in a discussion for a year just to figure out how to talk to each other. Because at the end of the day, collaboration is really hard. It's really hard to do it well. We operate in different structures, how we garner funds, how we teach, how we publish. And to bring those different structures and how we lead our days together is oftentimes very frustrating and lonely. And when I look back on the years of investment of time, I think that year just figuring out how to talk to each other was incredibly important, because we discovered that although we had many shared terms in terms of our language, we had very different definitions for those terms. So establishing a place of trust, of respect, and curiosity has been important. We are also very interested in establishing our core areas of disciplinary expertise. It's never been about operating as pseudoscientists or scientists operating as pseudo-designers, but coming to a shared table where, as an architect, we can contribute to scientific questions and problems. And the Science Robotics cover is a recent paper that we published with biological engineers in bioengineering on the topic of metabolism and looking at synthetic DNA. And we developed a series of simulations to look at that behavior. So over the years, a way of working, a methodology has emerged, and we typically start with the development of tools, software, writing scripts, algorithms, to model behavior. And that might be based on a particular data set coming from one of my scientific collaborators' labs. It might be based on a mathematical principle. Some of those tools are then brought into the realm of architectural prototyping, sort of productively contaminating the process with the stuff of making and materiality, which also, in a way, starts to negotiate the problem of scale. Not everything is scalable. And then some of those successful prototypes are brought into issues of building and the built environment. So it's a purposefully slow process to be rigorous and to also negotiate scale and the question of, what might be applied. I quickly learned that in order to garner funds that my colleagues and collaborators in the sciences were garnering from the National Science Foundation, the NIH, and so on, that one cannot get NSF funding without having prior NSF funding. And I was like, well, what the heck? How do you get one of these grants? So I owe a tremendous amount to my collaborators for showing me the ropes, figuring out how to manage, developing a budget and everything that goes into one of these intense proposals. And so I aligned myself with my collaborators as a co-PI and, eventually went after similar grants on my own with other collaborators. But this is a project called eSkin. We were one of 10 teams across the states in 2010 to receive a multi-million-dollar grant for a call from the NSF that dealt with issues of sustainability, particularly looking at building heat gain and high-rise tower structures. And we proposed the development of thin film technology in the form of building skins. And these were some of the prototypes that we developed from scratch. So getting this funding was incredibly important in terms of showing the importance of the collaborations and also being able to fund a number of students and incredible research associates to work collaboratively in both the lab and the studio context. I thought I would just very briefly show one of our current projects. I think Ron and I met over the topic of clay many, many years ago and our mutual interests in 3D printing. In my lab, I have undergraduate students, BArch students. I have undergraduates in material science, engineering. I also have graduate students in our MArch programs, as well as advanced degree research programs. And the best times are when we have a very diverse group of students coming together from diverse disciplinary backgrounds and experiences. And so this project is Polybrick 2.0. We've been working on the Polybrick series for about 5 to 6 years now, and this project is specifically looking at human bone as a design model, as a muse, working collaboratively with Dr. Christopher Hernandez, who's a mechanical engineer and whose expertise is in the mechanics of bone. So engaging issues of performance and optimization, to look at the strategic generative fabrication strategies and computational design strategies relative to how loads follow particular paths within a given media, in this case clay. So imagine a wall where the densest area is at the base, where you have the greatest amount of load, that then slowly becomes incredibly porous at the top. And so we've taken a deep dive into looking at these natural systems, in particular human bone, to optimize for these load path conditions, but also to deal with the more phenomenal aspects of what a porous wall can afford. Working across multiple length scales collaboratively with the engineers and with my team. I don't just maintain these research questions within my lab. I think it's incredibly important to take aspects of the core research that have reached a certain maturity and bring that back into the design studio, into our professional degree programs at all levels, from the core to the upper levels. And so, for example, the work with digital ceramics, 3D printing clay, and so on has framed a teaching trajectory for the last 10 years, where students take seminars and advanced studios working with clay to develop screen systems, load-bearing walls, and so on, again, working with a particular media. In my practice, I collaborate with a number of industry partners, most recently Microsoft, taking sort of a deep dive into advanced technologies, and in this case, working with artificial intelligence. I'm not going to go into depth on this project at all, but the one thing that I did want to point out is that these projects, although my team in this case are more senior, also involve students, interns, where again we're able to take topics emanating from the lab into application and to ultimately start to touch upon that third phase of how do these materials and modes of making and methods impact the built environment, and how we as humans interact with them as spatial interfaces. And then the last slide really is just to talk about this program, a new program that I launched 3 years ago, which for me represents the last 15 years of work trying to figure out and eke out a new model that is truly collaborative and hybrid. Because for me, the most important thing that we need to think about now is collaboration and inspiring and encouraging that hybrid thinking between design, science, and technology as a way of working. And the tools are facilitators in that context. And so this is a 2-year advanced Master of Science degree in Matter, Design, Computation, and we purposefully don't require a prior professional degree in architecture, and that's to allow other students coming from different disciplines to enter the program. So with that, I'll pass it on to my colleague.
Thank you so much for the invitation, Dean Curry and Doris. I appreciate participating in this conversation and look forward to it. So today I'd like to share with you a quick view into the research that's ongoing in SoftLab at PSU. And I think the setup of its lab and its work will show a version of pedagogical model relating technology to architecture. So At SoftLab, we're really interested in engaging the rich traditions of textile craft. The point being to engage spaces that are probably outside of science and technology, but are still fruitful places to look for solutions to many of today's problems. So we're interested in engaging those who would not otherwise be engaged in the discussion of science and tech connected to architecture. And as examples of these ideas, I'll present two projects on what I like to call computational textiles, which is what we work on in SoftLab, in the Stuckman Center for Design Computing, or the SCDC. So this is a picture of SoftLab in the SCDC. There's a computerized hand knitting machine, a computerized sewing machine, electronic bits, a soldering station for students and staff and faculty at Penn State to use, and it's open to the university community as an interdisciplinary space. And we have people working on projects from art, architecture, landscape architecture, architectural engineering, chemistry, electrical engineering, industrial design and engineering, earth and mineral sciences, and theater. And again, the point was to make a space and bring people of diverse disciplines together through research projects, courses, and independent studies in the lab. So students working in the lab range from PhD students to undergraduate students. And I try, as the director of SoftLab, to layer the students so that they can work together in teams on projects, so that PhDs are helping the Master of Science students and also the Arch professional students, as well as the undergraduates, so that people are kind of working up and working back. So there are two basic research directions in the lab. The first direction is more architecturally traditional, where we look at using textiles for sheltering. And these are projects like tents, shade structures, etc. And a second direction is looking at what architecture could be by understanding the augmented and sensing body and its environment. And these projects are things that you wear on your body, wearable clothing, or make the body as part of its system. So as architects and designers begin to understand the desired behavior of computational materials they use, they'll more and more have the ability to inflect and shape social space and relations and emotional effect with these materials, and will be called upon to do so. So my work with my students and other faculty and staff in SoftLab is to relook at the role of textiles in building, not just as a way to make lightweight structures, but really to think about how architecture could be restructured. So let's have a closer look at what I mean by computational textiles as a material. If you really start to think about it, computational textiles change the idea of what is a material. A material may be seen like the above image, where a designer is weaving together a person or a body monitor such as a heart monitor, a mobile phone, a laptop, a set of responsive yarns or fabrics, a power system, and at large, the environment. So this drawing just shows one example of a textile material system. There might be some textile material systems that also include other parts, such as a person who might be looking at what's happening to the heart monitor, or a manufacturer that might be connected to a wearer. So I'm going to take you through a couple of projects that show the two trajectories. The first is the Phototrophic Pavilion, and it's a project that my students and I did for an invited competition, spring of 2018. It was sponsored by the American Composite Manufacturers Association, who provided resins, fabric materials, and expertise for the competition. And it was an opportunity for the students to look at folded plate structure to understand potentials for flexible and composite structures. This project was exhibited in London at the Textile Intersections Conference and will be presented at the ACSA Open Conference in March by the 3 students on this team. And as a team, we decided that the project would work with light. And it had two modes, one for evening and one for daylight. And here you can see the evening mode when the light could shine through the fiberglass and the LEDs were on. The surface of the final folded fiberglass and resin mix was quite translucent, so it was able to carry the light pretty well. But really, the innovation that we worked on with this project was fairly straightforward. We looked at the manufacture of this fabric and introduced conductive thread into their base material so that we could use the current flowing from batteries that we connected to the fabric to light up LEDs, so that the fabric had other capacity, was augmented by simply adding electricity and having a soft night light. And here's the daylight mode where you can see some of the texture. So the second project I'm going to show uses clothing as a way to think about architecture. For Soft Lab, this project started as an exploration of space-body intersections. And you may be wondering, why is an architect looking at sensors on a body? Well, there were lots of intersections with this project. It's a really interesting history. As with most of the projects that we do in Soft Lab, it's highly collaborative. It was done with Conrad Tucker in mechanical engineering, who's an expert in machine learning, and Delia Dumitrescu at the Swedish School of Textiles as well helped manufacture some of the pieces of this project. Also, students Yi Dong from the School of Engineering and Industrial Design, and my student Vernell Noel, PhD, now faculty at Georgia Tech in the School of Architecture. So we had talked about this in my lab originally as working with dancers, but I had run into Dr. Tucker at a conference, and he had been working on a paper. And so we talked about that paper. We came up with a couple of prototypes. The one on the left was the first prototype, taking tape. What we were trying to do is map the position of the hips, the knees, and the ankles so that we could tell what a person's legs were doing. So the point was to make a wearable that you could understand what the body was doing in space. And so on the left is the first prototype, and then on the right is probably maybe 2 or 3, and with portable lily pads, et cetera, and microcontrollers on it. So Dr. Tucker originally used a Kinect sensor to characterize someone's walking pattern, which is a camera-like sensor. So you could map where someone's legs were going. However, this was really restrictive. You had to be stuck in a room where the camera was. And so what we tried to do instead was put the sensors on the body so that someone wearing these could go for a walk, get the groceries, et cetera. So this was really the point of the project, to see if we could compare the data between the two and put the sensors on the leggings. The other thing that we wanted to do was we wanted to make sure that we used off-the-shelf sensors that we could get easily from SparkFun in our lab. We try to use inexpensive equipment in our lab so that many people could prototype on their own. They could look at our project in a paper and say, hey, I want to try working to modify this in another way. So we try to use inexpensive things. I did show this project at a couple of different engineering conferences, and many engineers had some very nice infrared sensors that we could have used, very interesting technologies, but the problem with that would have been to cut off, I think, an audience that might have been engaged and invited in by having less expensive tools. So we've been talking about that and going back and forth with that. So the design system with a computational textile is super important. Who should see the data? What may be done with the data? And these are questions that I think are different from what might emerge compared to if one had started this as a building science project, for example. So we start to look at culturally how these change our lives and how they're affecting the way we live our lives. So with that, in closing, the contributions to architecture made by Soft Lab is really cultural, social, and technical. And these materials really change how we think about our bodies in an environment and a space. So with that, I look forward to talking more with you about this. Thank you.
So at this time, we'd like to invite the panelists to come up to the podium or the stage and to open up the floor for questions. Let me again put this up again for those of you who didn't get it before. Okay, so I actually want to start off the conversation by asking the panelists here about their own background, right? And how they came to what you do now, and how your education helped you get there or didn't help you get there. What were the influences in your life, and how circuitous it was, or direct, if you were interested in doing this at a young age, if it was something that you fell upon accidentally or intentional. So if we can possibly do that, that might start off the topic of education.
Sure, I'll start. Is this working? Can you guys hear? Okay. So I had no idea that I was going to end up doing this at this point in my life. I started out as an engineer. I always knew I wanted to do architecture. So get that. I ended up in engineering first, did the technical, and then did grad school in architecture.
What kind of engineering?
It was general engineering. So I did a little bit of civil, a little bit of EE, a little bit of ME, it was a general degree. So I had no idea, but what spurred me to get into this was really seeing, as I was teaching before going back to doing a PhD, as I was teaching, I was seeing the field change and seeing all these new tools come up and all this exciting stuff going on. And I knew I needed time to learn it, and so I decided to go back and do the PhD, and then was able to see other people working in ways that were interdisciplinary, and that's how I ended up now where I am, and I'm very excited.
And what did you get your PhD in, or is it engineering? And
No, it's not engineering. It's design and computation. So looking at design and thinking about ways in which people make design or think about design through computing. And computing doesn't necessarily mean computers. So actually, I agree with Jenny's comment about I don't like to call myself a technologist. I'm a designer, which is a broader term, but I like to think about ways in which design is structured.
I touched on it a little bit, but I grew up in a very remote, small village in a sheep ranch on the border of New Mexico and Colorado. And I think that everyone in the village was my family, actually, and everyone knew how to grow their own food and build their own house out of mud. And I think I was very much part of a culture that made things, and I didn't realize that. But when I went away to graduate school, I studied at Columbia. I was studying at the time when computers were probably at in their infancy. It was the first year of the paperless studio, I think, at Columbia, where imagine like using a computer was an amazing avant-garde thing in architecture. And I was studying under modernists like Ken Frampton, and so when I was homesick, I would go to the library and I would look at the architecture of where I was from. At the same time, I was studying computer-aided design and I was studying modernity, and I wondered about the three things coming together. I wondered about those three worlds. And probably my first academic endeavor was to write a book called Earth Architecture that was looking at the history of building with earth as a technology, looking at its integration into modernity and how modern architects were using this traditional material and speculating about the future. And at that time, in 2008, that I wrote this book, I was thinking, well, what is the future of earth and architecture? And I wrote, oh, it must be 3D printing. And then I said to myself, well, I want to be that guy who does that. And so I think in the same way that the people I grew up with could do anything, they just took on that task, whether it was building a house or growing a garden, I took on the task, and maybe admittedly not very good, of saying, I need to figure out software, I need to figure out hardware, I need to figure out materials, and allow that to come together in a way.
So I also grew up with makers. Both my parents are artists. Grew up with looms around the house, and my dad painted and also did a lot of work with clay. And we worked on our house, remodeled our house for 10 years. So I grew up, I think, with a confidence and a facility with materials and making and taking part in the making of our home. And I struggled, actually, for a long time to try and figure out a way to integrate my interests in the arts and mathematics and the sciences, because I was good at both. And so when I started college in the 90s, which seems like a very long time ago, I started in biochemistry, which I think was my own rebellion against my artist parents. And thought I wanted to go into medicine, and then quickly realized that that wasn't the right path, and ended up doing a BFA in ceramics and a BA in interdisciplinary visual art. But I still was struggling to find that fit, and that's why I ended up doing my graduate work in architecture after several years of trying to figure that out. And like you, Ron, I had a wonderfully kind of schizophrenic and fraught graduate education because at Penn at the time, they also were going through the transition from sort of manual production of drawings, Mayline, et cetera, to the use of the computer. And so I spent the first half of my education learning those traditional techniques, which as a maker coming from the fine arts was a good transition. But then the second half, working with people like Cecil Balmond and others, writing scripts, and this whole world opened up, and I was like, oh, this is it. This is the the thing I've been searching for. So for me, it's been a process of making decisions, but also a commitment to really trying to find that point of integration across science, math, technology, and the arts.
Yeah, I think you bring up an interesting topic of this making, right? And being a maker. And all three of you talk about how it was influential early in your life. But given the education now, and many of our students don't necessarily have that history of making, nor do we see it as much in architecture programs, do you think it's going to change that value of making? Is it a generational thing? Is it something of the past? Is it something that transforms itself for the future? Do you see differences in your students? Is there going to be more making or less making?
I'll start. Absolutely more making. I mean, some theorists and historians argue that we're amidst the biggest paradigm shift to hit architecture since the medieval period. Mario Carpo writes about this extensively, where the architect is being repositioned as a maker again through the technologies and ways of working fluidly in terms of design intent, from algorithm to material output, through the advent of 3D printing and so on. So I think the issues of making and craft and considering how geometry, materiality, pattern, construction, program, context are all inextricably linked as a scenario are ever more promising. So I go back to the quote that Milton started with in terms of the contractual hurdles and pitfalls that sometimes we're up against, and I really think that will hopefully shift.
Yeah, sure. So, to answer your question about making, I think that just having thought about computing, that really there's been a lot of work to engage the whole human body in making, in thinking, not making, thinking. And with this comes making, because your body's engaged. It's sensing, it's smelling, it's tasting, it's touching. And so I think there will be more making as our technological tools get better. Right now they're very crude, very, very crude, right, compared to what we can do as humans. That I think as they get better, they will engage our bodies more and there will be more making.
I have another question. I guess this is a little more complex and may go in the direction of what you guys want to talk about. But when we talk a lot about the making nowadays, oftentimes we talk and include, as you have discussed, this idea of optimization. On one hand, it's about optimization. On another, we talk about this idea of intelligence, smart AI, you know what I mean, these types of things. Is it, and I say smart because these words are used very, very broadly, right? So we have smartphones and we have smart gadgets and we have smart water. Not really, but where and how does this incorporate into architecture and design when, on one hand, engineering is all about this kind of optimization? Should it be a goal of architecture? Should we always be looking towards that? When in a time where in engineering, the shortest distance between point A and B is a straight line, but in architecture, that's not always true. Culturally, you know, engineering-wise, etc.
It could also be, don't you think that it could also be about, there could be other things that technology does in addition to optimization and efficiency, right? Those are things that we think of right off the bat, the top of our heads. But there's also freedom of expression, being able to do something that your body couldn't do, you know, if it were different. So there are all these other potentials that I think technology can bring to design.
I don't know if I think engineering is about optimization. I think engineering is about litigation, and that there are so many factors of safety that, and so many redundancies and so many barriers that it doesn't become an optimized scenario. It becomes something very different. And you know, someone's work who I admire quite a bit, Mark Fornes. I think he's doing things that are moving in the direction of optimization, but without attempting to have some kind of morality of efficiency. I mean, it's really about these beautiful gestures, but really what he's doing when he's combining computation and material, he's doing things that engineers would not dare do, and he's solving them himself in a really cohesive way.
So does that separate him from being an engineer, and does that make him more of an architect, or does it make him something else? How?
I think it makes him something else, and I don't want to define it, because some people might say, well, he's a public artist, but he's trained as an architect, but he's doing things in engineering. I think he's doing something very novel, I think, which is blurring the boundaries and not attempting to be part of any kind of particular silo. And I would say that would be the same to what I would say about Felicia and Jenny's work, is that they are also expanding these territories and not trying to be in any kind of silo.
Yeah, sure. Just in terms of optimization, you know, in our case, if I use a specific example, the Polybrick project that I briefly presented, you know, we quickly found that a lot of the topology optimization tools were extremely flawed, right? And actually, the models based on human bone are a lot messier, right? In the way that energy is negotiated, the way that forces flow through geometry and matter, how context specifies form, function, structure. If you look at the cross-section of the density of the bone of a swimmer versus a bicyclist versus a runner, it's going to look radically different. And the tools to negotiate optimization are kind of they're crude. They're crude, and they don't even begin to negotiate the complexity of the natural systems that we're looking at. But related to that, I don't think I agree with you about your comment in terms of the relationship between engineering and optimization. It makes me think of this really fantastic competition that Arup London had with Arup New York, and this was about 15 years ago, because genetic algorithms were first used in many ways for structural engineering problems. And in the competition, the team in London used their GAs, kind of black box crunching of data, and you get a whole set of solutions. And the team in New York just relied on sketching. And they were both working on the same problem. And the team in New York actually arrived at the same, if not better, solutions than the GA did. So,
Interesting.
Yeah.
Interesting. Do we have questions from the audience?
We have many people.
Oh, okay. Awesome.
Yeah, I think so far we received about 7 questions. So, and then I think yeah, one serious question is for Jenny, and another serious question is, and third question is another one is Fletcher. So I think it's a really good balanced. Okay, so let me read very clearly. Okay, actually, yeah, some guy seems to send 2 questions. So let me combine all together. Okay, hi Jenny, I'm a fan of your work. Okay, good. Who are the architects that influence your work in your early career? And also tell us about the project at Microsoft project a bit.
Thanks for the question. Architects that have influenced my thinking, my heroes, there are many. One, Robert Luricole, he was an architect and a structural engineer, designer, who was obsessed with looking to nature for design models to understand morphology, and his obsession with understanding the beauty in failure. And he's the father of the space frame, and he pioneered corrugated sheet metal and many other systems, but through a process that engaged computation, albeit through analog models. Another person, probably my most important mentor, Cecil Baumond, also a structural engineer, a pioneer in form and algorithm. Gaudi, Frei Otto, Ann Ting, people who worked with computation pre-computers, but worked systemically and relationally, parametrically, constantly moving back and forth between analog and material investigation, and how that could be applied to architecture. And there are many, many others. Also scientists, Conrad Waddington, Darcy Thompson, and others. The Microsoft project, I could give a whole lecture on. It is, to our knowledge, the first architectural pavilion to integrate artificial intelligence. It was incredible to work with Microsoft Research and work with teams engaging AI. The researcher and his team that I worked with, Daniel McDuff, he's interested in AI in terms of looking at facial patterns and human sentiment to understand how our environments impact us, and in turn to develop tools and technologies excuse me, that could hopefully promote well-being and health and wellness. And so Ada, in ode to Ada Lovelace, who is oftentimes credited with being the first computer programmer, celebrates that technology, but fundamentally the mission is to make it human, to open up dialogue around some of the pressing issues around AI and privacy and so on, but to really think about what an interface could be, an architectural interface engaged with AI that is driven by humans, empowered by the technology. That's a very short summary.
Great, great. Okay, so and next question is, I think it's for Ronaldo. It's very technical. So with the use of clay, what is the concern in mobility in relation to the weight of the material? So did you try other materials instead?
So the question is, if I tried other materials other than clay,
Right, because of weight.
because of weight, yes.
What is your concern?
I think, if we've experimented with lots of materials and materials that are mostly. When we started this work, we were looking at materials that existed with a 100-mile radius of where our research, and also that the software and hardware would come from a 100-mile radius. So the sawdust come from sawmills in the Sierra Nevadas, the salt is coming from the bay, the Chardonnay grape skins coming from there. I'm losing them. Look at that. They're leaving in droves. And so the clay is part of that ethos. And some of the materials are heavy and some of the materials are light, but fundamentally, and that relates to maybe how they're used structurally or how they're used as cladding. But fundamentally, all the materials are from a place and part of an ecology. And that's the goal of the exploration.
Thank you very much. And yeah, Valencia. So with your interdisciplinary background, how do you figure out what you truly want to pursue from the broad range of topics?
Wow, there's a couple readings to that question. I'm trying to figure out which one the person meant, but I'll take it as, maybe I'll restate it, how do we decide what to do on a project, in an interdisciplinary project? I'll take it that way. So, there's a lot of arguing, basically. We sit down at the beginning and we hash out where we think we want to go with something. And there is a discussion about many different issues such as funding. Jenny mentioned funding. If you want to do a project that goes after funding, it will be this type of project. So we haggle back and forth about, we're going to go for NSF funding? No, not this one. We want to explore more over here. We want to do something artistic. We want to do something with dancers, or we want to do something with this particular group. So it's really a haggle, and I would say that haggling kind of never ends in a project. It goes back and forth. So that's one way to take the question. Another way to read the question is also, with all this stuff going on in architecture, how did I pick maybe textiles? And how did I choose that particular thing? And I have to say that particular one is personal. I picked it because it was something I was interested in since I was a kid. I like to sew, I like to make things, I like to knit. And when I walked into Leah Beakley's lab, who was my dissertation advisor, her lab was at MIT, I saw all these incredible things that were familiar to me that were like a sewing machine and yarn and all this stuff that I knew I could make things really fast and prototype really quickly. And I saw that, and she was basically making these really innovative projects with it. And she was getting patents for things, and she was making things, and I was like, wow. So that blew my mind, and that took me in that direction. I was very excited by that. So it was personal. That's another way of answering the question.
Great. So I may have some follow-up questions for all of you. So I know that you guys are really great work, and it is really exciting for us to learn from the very best case study. But I'd like to ask you about your some worst case. So in your any activity during your career or during your research activity. So for example, I clearly remember in 2013 when I went to NSF's panel, and then one guy said that I think he's from engineering faculty. He's very senior. He saw some proposal from architecture school. Hey, how architecture school faculty can do research? We need to keep up to reviews. It's really kind of low quality. So what do you think, Junho? And then my batch said that I put some building science in architecture USC, but because of number of limit in my batch, Juno Choi, building science, School of Architecture, instead of School of Architecture, it said S. So that's it. So that's why he thought that, oh, he might be from engineering. So he tried to ask for my agreement on his some opinion. Okay, but recently, fortunately, it is not much happen these days. So, but it does still happen. I know. I heard from here and there. So, and the other one is that during the career, yeah, many people say interdisciplinary study, multidisciplinary study, but it's not easy to implement at least at the beginning point. So in some case, my worst one is that I tried to meet some really big guy in engineering, but he almost kicked me out from his office, just to treat me as like a salesman. Yeah, but it happened. So yeah, but I don't care. I tried to not care, but I was hurt. So I'd like to ask you any episode or any worst case moment during your research development, especially in a technology-oriented topic. Too many.
Well, I mean, it depends on how you answer the question. I guess in the context of the research and the process of doing the research, so much of it are productive failures, right? Necessary failures to move forward. And that's how new knowledge is produced and the successes are produced. Another way of answering that question is, I guess, related to my practice. It was towards the end of installing Lumen, which was my project for MoMA and MoMA PS1 YAP in 2017. And we had been working insane hours for almost a month. And we were nearly finished with the third tower. There were these 45-foot tall tensegrity towers that lifted the canopies up and were crazy in and of themselves. But we were taking this steel easel off of the third tower, which would prop it up until the ropes were fully tensioned. And to do that, the installers had to cut the steel. So we had torches up there. It was like 3 o'clock in the afternoon. Finally, it's like, we're almost done with this. I'm going to go eat something. I came back, and the ropes had caught on fire, which meant we had to start all over with that third tower. So there are those moments too, but that was a particular project. And then I guess the third, just briefly, I've had some similar situations where I've had scientists, really incredible scientists, approach me to take part in a proposal. And for whatever reason, I seem to be the poster child for like the weird arty architect person that could actually do NSF stuff, like whatever. And there was one instance where I was super excited about this team, but in the first call it became so apparent that they just wanted my name on their proposal, and there wasn't a genuine interest in collaborating, over the longer term, and I actually just exited immediately. So there are those kind of structural scenarios you have to navigate.
Well, I have a friend who is an author, and she told me once that when you learn to write, you are taught to write in the first person, and eventually to hone your craft, you have to then write in the third person, and it takes time to get there. And I would say that what I've realized, and even listening to both of your stories of what inspired you that got you into this, is that in architecture, you're taught architecture in the third person. In other words, you look at precedents and you look at the masters and you look towards modernity, you look towards Europe. And many people stay there. They stay in that third person in the abstraction. And I think that it took me a very long time to realize that I can do research in the first person, that the work can be about central to what I'm interested in and not to what people think is interesting. And I would say that was I wish I would have realized that sooner. And if this is about thinking about educating technologists, I would say look to what interests you now, like what's fundamental to who you are as a student. Learn about modernity, learn about all these things, but don't think that you have to be Frank Lloyd Wright. Don't think that you have to be. You not be that person who you are going to be. And it actually took me a long time to realize that my interest in mud, which people, I remember walking into Kenneth Frampton's office and say, hey, did you know that Le Corbusier shut his office down for a year to write a book about building in mud in France? And Frampton said, no, he didn't. And he told me to leave his office. And, it's just these moments that you realize, oh, well, you think there's something wrong with your fundamental interest because they are not reflective of something that's perceived as bigger. And so that's where I think the failure was. But again, it's a productive failure.
Great. Yeah.
Well, I guess I could add something to that, related to what you're just saying, Ron, that I think carving out a space for textiles is pretty hard in a school of architecture, and then also having scientists take it seriously. And one of the things that really helped where I am was the structuring of internal grants. So I know this sounds incredibly mundane, but what that did was it meant that scientists came looking for me to be on their grants, and I came looking for them because the grants are structured so that you had to have someone from a different college, interdisciplinary, to be on there. And so there was a kind of inbuilt friendliness, like immediately that way. But I think that every day you're sort of pushing against what you're saying, Ron, with your sort of experience with going into Frampton's office and saying, I like mud, I want to deal with mud. I like dealing with textiles. I would like to innovate with textiles in architecture, and so you got to really constantly push. So.
Are there any more questions from the
Yeah, actually, continuously we have some many other questions. So do we have time? Or?
I think maybe one more question, and I want to close with a question as well.
I think it is quite technical but very important, I think. So I think this question is from very modest guy. Okay, thank you for your taking time from your busy schedule to being with us today. That is part of the questions. Okay, so in the information age, so as a designer, we are always surrounded by data. So what is your role to see the data informing design? So there are a lot of AI technology available these days, and I also receive such a question very often. So information, big data is available these days. So how can we incorporate in a design study or design process?
Well, for me, the onset of big data actually formed a bridge with some of my early collaborations because the sheer amount of data that is now being produced in the context of doing science is also changing the way that science is done. So rather than looking for discrete singular events, you're looking for trends, amongst data. And so early on, the tools and synthetic thinking that I brought as a designer to those problems actually had immediate application, which blew me away, that I could operate as a designer in that context, helping to make sense of the data, holding data. Imagine if you 3D printed data, which is something we did with our printer from the get-go. How could that contribute to the scientific process and allow the scientist to project into the problem in a different way? And then just a side note, I think that in the context of AI and big data and that light, it's very much of our time in terms of the kind of statistical sorting of data to find particular things. And I'm excited to see where the tools and the technologies take us next in terms of how we as humans engage that.
So that is a huge question. I don't know who asked it, but you could use AI for almost anything. So really, it's looking at feeding a machine huge amounts of information so that it can help you make some decisions. And so now I have a PhD student who is working with tension structures, and we're knitting them on a hand knitting machine. And she wants to determine for a particular pattern and a particular tension what the end result will be. And she's using a camera to scan the surfaces that she pulls out in physical models. And then she's changing the pattern and asking AI to find the shape at the other end. So it could be whatever you want it to be. I mean, really, it's a huge question. So, you know, in terms of understanding more about that question, I would get online and see some uses of how other people have used it. They used AI in, like a fashion house to design dresses. They went through all the color trends, picked the most popular colors. They picked the silhouettes for a dress. They picked the type of, ornamentation for a dress, having looked through thousands of pictures of people on red carpets. So you can do so many things. Yeah, it's
So I want to close with one last question, bringing it back to education. And we still have a lot of students here. Thank you for staying. But what would be your advice to students who are interested into being makers, working with computation, thinking about AI, optimization, all these different things, materials, and what kind of advice would you give them of how to pursue that from here in architecture school and after? No advice. Come on, Ron.
Yeah, sure. All right. I guess my advice. These are hard questions. I would say that you should enjoy the work you do. I mean, my biggest advice, no matter what you do, if you enjoy it, you're going to get good at it. And if you are good at it, people are going to ask you to do it more. And there's a certain amount of happiness that comes with that. And I think you should kind of find that momentum and do not be afraid of, if technologies seem outside of your grasp, I think you should find ways to bring them within your grasp. I mean, all of the research that we have done in 3D printing is fueled by the fact that we didn't have access to it, and we wanted access to it. And so making materials out of salt, if you bought 100 pounds of powder, it costs like $3,000. But then we realized, if we make it out of salt, it's going to cost $25. And that's how we were able to build big things with 3D printers. And then we realized, the machine itself costs $40,000. Why don't we make our own machine? Why don't we make our own software? And I think that you can't, I think there's this assumption that technology exists out there and it's produced for you and you consume technology by buying it. But I think you have to realize that you can empower yourself to make technology. That's what we do fundamentally as humans. That's the nature of what we do. We make technology. So just make the technology.
My advice, I think, there's a lot that's being thrown at you. You listed a whole number of things, various technologies, tracks within design and architecture, the building sciences, computational design, and so on. And just remember, it doesn't mean that you need to do it all, right, or know it all. And my advice is to be a collaborator and do the thing that's oftentimes the scariest, which is to go into buildings that you don't normally frequent and knock on doors that you don't normally knock on and have conversations with other students in different departments, because amazing things can happen when those different worlds are brought together. And, maintain your disciplinary expertise and have confidence in it, because design right now, it was mentioned a number of times, everybody wants it, right? And we need to get a lot better at feeling confident in what we have to offer and bring to the table. And so I just encourage you to go out into the world, into your local world here in this incredible university, and foster those discussions.
So I guess my advice would be, don't be fooled by technology, really. Ask what you want to do, and then see what's the appropriate way. And then that will be the technology. You will find your way to what you need to do. So I would say, I think that's my advice, really, is what do you want to do? And then find the way to do it. I know that sounds really vague, but sometimes people get really caught up in all the new technologies that come to the foreground, and they're not necessarily, at the end of the day, when you boil it all down, all that useful.
Thank you. I'd like to thank our panelists. Thank you all for staying. Thank you to the school and everyone who helped make this happen.